Hello and welcome to LociMania. Today we're going to speak about the glycolysis pathway. In this pathway we have 10 reactions. I'm going to go through them. A short overview. The first substrate we start with is glucose, which then gives us glucose 6-phosphate. As you can see here on this arrow, this is an irreversible reaction. Glucose 6-phosphate gives us then fructose 6-phosphate. And then fructose 6-phosphate will give us fructose 1,6-bisphosphate. And as you can see on this arrow as well here, this is an irreversible reaction. We will have 3 reactions that are irreversible in the glycolysis pathway. They are really important to memorize. We're going to go through them a little bit more soon. So from fructose 1,6-bisphosphate, we'll get DAP, dihydroacetone phosphate, and glycerolaldehyde 3-phosphate. This DAP will become a glycerolaldehyde 3-phosphate as well. And that will generate 2 glycerolaldehyde 3-phosphate. So everything you see here is times 2. So glycerolaldehyde 3-phosphate will give us glycerolaldehyde phosphate, which then give us 1,3-bisphosphoglycerate, and then 3-phosphoglycerate, 2-phosphoglycerate, phosphonyl pyruvate, and lastly pyruvate. This is the end product of the glycolysis. So pyruvate is the end product of glycolysis. Let's move on. So we have some ATP reactions that I would like to call them in the glycolysis. This is a short for reactions. So the first 2 ones are the ones that require ATP. Glucose to glucose 6-phosphate require ATP. The enzymes here are hexokinase or glucokinase, depending on what state your body is, what metabolic state. Please watch that video, which I'll explain further about the hexokinase, glucokinase. The second one is from fructose 6-phosphate to fructose 1,6-bisphosphate. The enzyme there is a PFK1, which is a rate limiting step of the glycolysis. So these are the ones that require ATP, and then we have the ones that produce ATP. This is the 1,3-bisphosphoglycerate, which gives us 3-phosphoglycerate. The enzyme here is phosphoglycerate kinase. It produces ATP. The second one here is phosphonyl pyruvate to pyruvate. The enzyme there is pyruvate kinase. It is activated by fructose 1,6-bisphosphate, but inhibited by ATP and alanine. Let's go through here. So here are the 3 irreversible steps that I was talking about. They are really important to memorize because in the gluconeogenesis pathway, we'll have to have some steps that will overcome these steps. So the first one is glucose to glucose 6-phosphate. The enzyme there, as I already said, is hexokinase and glucokinase. The second one is fructose 6-phosphate to fructose 1,6-bisphosphate. The enzyme is PFK1, which is the rate limiting step of glycolysis. And the third one is PEP, phosphonyl pyruvate to pyruvate. This is the last and final step of the glycolysis. The enzyme there is pyruvate kinase. As you can note, as you can note here, they are all involved in the ATP reactions that I mentioned earlier. We also have one here, reaction that I'll call NADH reduction. It is from glyceroldehyde 3-phosphate to 1,3-bisphosphoglycerate. And the enzyme there is glyceroldehyde 3-phosphate dehydrogenase. It will reduce NAD plus to NADH plus H plus. So this is NADH reduction, also important to memorize. This will then go to the electron transport chain and give us ATP. It will give us 3 ATP. As we can see here, what to memorize about everything that I just said. We have 3 irreversible steps. They're important. or maybe not so important in the gluconeogenesis, because in the gluconeogenesis we'll have to have other substrates so we can overpass those reactions. Arsenic poisoning give us 0 net ATP. Watch that video about arsenic poisoning in the glycolysis pathway. Also, the last enzyme, pyruvate kinase, partial pyruvate kinase deficiency will give us hemolytic anemia. Also watch that video about the pyruvate kinase deficiency. DAP give us, we could synthesize triglycerides by taking this intermediate substrate from the glycolysis. We then can synthesize triglycerides. We have we use hexokinase when we have decreased glucose in the body, and glucokinase when we have increased glucose in the body. This is in the liver, and this is in the most tissues, liver and pancreatic beta cells. Also watch the video about hexokinase and glucokinase differences. That was all. Thank you, and please come again.